So this is Geometry Semester 1. It's the second unit called Angles, and it's the sixth lesson called Parallel Lines Cut by a Transversal Practice. It's on creatormath.com. You might have to type in creatormath.weebly.com into Google to find it. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So, let's see if we can find this. Let's just go there quickly. It's creatormath. Okay, move out of the way. creatormath.weebly.com. Here's what the home page looks like. There it is right there. Make sure you're under the Geometry tab. Pass by all the vocab stuff. This is all the PDF of vocab you need for the entire school year. Go to the right semester. All right, semester 1. All of this semester 1 table of contents should have been copied into your comp book into pages 2 through 6 already. If not, stop and do it right now. We're going to go down to the second unit. The second unit right here, parallel lines cut by a transversal practice. It goes on these pages of your comp book. Please look at the actual table of contents. During the time you're watching this, this is going to be different. And we're going to click Notes. And you will see all about parallel lines cut by a transversal. You have to talk about vertical angles, same side interior, supplemental or supplementary, alternate interior, alternate exterior, corresponding angles, same side exterior angles, and all their relationships. All right, copy those notes into your comp book first before doing these problems. All right, let's get on with the problems here. So, given the following parallel lines cut by a transversal, if angle 1 is 50 degrees, what is angle 2? So what you're going to see all the way through this practice is here's a parallel line and here's a parallel line. They are parallel to each other. They're aligned because they have arrow tips, arrowheads on them, so they go in those directions forever. They lie in a plane and they never touch or cross. You'll see the parallel symbols here. That means these two are parallel to each other. Then you'll see a transversal cut across this. The transversal creates 1, 2, 3, 4, 5, 6, 7, 8 interesting angles. The bottom line is that the relationships in two parallel lines cut by a transversal is either one of two things. Either the angles are going to be equal or the angles are supplementary. Supplementary is where you have a straight line and two angles on it, say A and B. This is angle A, this is angle B. Angle A plus angle B must equal 180 because this is a straight line in this measure here. That's supplementary. All right, so supplementary. Can't write and I can't spell. Supplementary. All right, supplementary angles, they sum or add to 180. So now they're giving us number 1 is 50 degrees. This is 50. What's angle 2? That's right here. It's on a straight line. They're supplementary. So they have to add to 180. So what adds to 50 to equal 180? 130. And there's a lot of problems in this set, but they're going to go very quickly here, and I'm going to start speeding up. Angle 1 is 50. And angle 2 is 130. What is the reason? They are supplementary. Well, there you go. So now they even tell you, even if you didn't know this first, now you could go back and answer problem 1 if you didn't know it already. Because they just told you this is 50 and 130. All right, this is one of these problem sets where it's not so much to test your knowledge, it's more to help you understand, okay? That's what its goal is, all right? So given the following, if this is 50, 1 is 50, what's 4? What's this right here? Well, they are what's called vertical angles. They're across from each other, so this has to be 50 degrees. I bet they tell me now. They sure do. They say if this is 50 and this is 50, why? Well, vertical angles, you guys. That's the name of it. And remember to draw an X when you do vertical angles. These are equal and these are equal. Draw a plus. These are equal and these are equal. They don't necessarily mean vertical from each other. They literally mean across from each other. All right? We cover that a bunch of times in all the lessons for vertical angles. An annoying name. They should have named it across from each other angles. And vertical angles are equal. If this is 50 degrees here for angle 1, what is angle 8? Wow, what's this? Well, they're on the outside of the parallel line, so they're called exterior, and they're on alternate sides. So there's only two relationships, either they're equal or supplementary. Angle 1 looks like angle 8, so this is 50 degrees also. So 50 degrees, and what's the reason? They're alternate exterior angles. You guys, what is the reason for this? They are alternate exterior angles. They're saying if this is 50 and this is 50, why? They are alternate exterior. Alternate because they're on different sides of the transversal, and exterior because they're on the outsides of the parallel lines. Interior will be in here, these four. Given the following parallel lines cut by a transversal, if one is 50 degrees, what is angle 3? So what's this right here? Well, they're either equal or they're supplemental. So since they're on the same line, they got to be supplementary. So they must sum, this has to be 130. They must sum to be 180 degrees. I bet they're going to tell me it's 130 now. This is pretty cool. They're going to ask me why. They're supplementary angles because they're on a straight line. This angle here must be 180. So if this one's 30, this has got to be, or if this one's 50, this has got to be 130 because it must sum to 180. Right angle 2 is 50 now. What's 7? What's this one? Well, they are alternate exterior angles. Alternate because they're on alternate sides of the transversal. Exterior because they're outside the two parallel lines. So if this is 50, this is 50, and they are alternate exterior angles. If angle 2 is 50, what's angle 3? Got to be 50. They are vertical angles. If this is 52 and this is 50, angle 3, then why? Vertical angles. There's a lot of problems in this set, but I think they're very easy once you get the hang of it. All right, what do we got? 3 is 50, so this is 50 degrees. What's angle 6? So these are called alternate because they're on different sides of the transversal, and it's interior because they are on the inside of these parallel lines. So this is called alternate interior. They are equal. If they look equal, they are. There's only two relationships, equal and supplementary. So if this is 50, this is 50. They're going to ask why now. They are alternate interior angles. They're on alternate sides of the transversal, and they're on the inside of the two parallel lines, so they're alternate interior. All right, given the following parallel lines cut by a transversal, if 4 is 50 degrees, what's 5? Well, they are alternate interior also, so they're equal. If this is 50, this is 50. And look, this is an obtuse, so it's 50. This is an obtuse, it's 50. They're just labeling in numbers, by the way. Remember that it does not have to be drawn to scale, right? So nonetheless, the location here equals the location here. If you tell me this is 50, I know this is 50, all right? Stick with what they tell us, not with the way it's drawn. They're always going to say, oh, it's not drawn to scale. If 4 is 50 and 5 is 50, these are alternate interior. What's the name? Alternate interior angles. They're on opposite sides of the transversal, and they're inside the two parallel lines. Alternate interior. All right. If 4 is 50 degrees, what is 6 right here? What's this one? So these are same side interior. They're on the same side of the transversal. They're both over here on the right, and they're inside the two parallel lines here and here. So they must be, they're supplementary. 50 plus what is 180, 130, and they're called alternate or same side interior angles. Same side interior angles. Given the following parallel lines, if 3 is 50, this is, so 3, and angle 3 is 50 degrees. 50 degrees. What is 5? They're same side interior, so they've got to be supplementary. 130. Same side interior. 3 and 5. They're on the same side of the transversal, and they're interior of the two parallel lines. All right, 1 is 50, and 5 is 50. Why? They are corresponding locations. So if you look at this, here's this intersection, right? We've got this one in the top left. Now look at this intersection, exactly the same, and this is top left. If this is 50, this have to be 50. They're called corresponding locations. Same placement, but on a different intersection. So these are two different intersection of lines, but the same position. So 50 and 50. And they're called corresponding angles or corresponding locations. All right, 3 is 50. What is 7? 50. So again, these are corresponding locations. This one's down here in the lower left, and this is the lower left. So they're both equal. They're both 50. And they're called corresponding angles. Definitely see a pattern here. All right, if 3 is 50, oh, look at this. So this is just 1, 2, 3, 4 angles now, or 4 intersections creating 4 angles each, or 16 angles. If 3 is 50, if this is 50 degrees, what is 15 right here? Well, let's just look at this. This is the bottom left location, so the corresponding location is here. If this is 50, this has got to be 50. They look the same, don't they? And you know, so 50 degrees here, and they are corresponding angles, corresponding locations. And maybe if I can show you one thing before we go, because we're done now, I believe, with a lot of problems. Let's say we took a piece of paper like this, and I don't think you can see it, but here's the intersection right through the paper. So if they say this is 50 degrees, and then we slide this over, given parallel lines cut by transversals, and we put it right here. Notice how it lines up, and I don't know if you can see them through. I kind of can. This one right here is 50 also. It's the same exact measure. See it? This has got to be 50 also. Oh, that's kind of good. I don't know if you can see that, but it lays right on top of it, right? So that's what corresponding angles or corresponding locations are in geometry. And they're equal. Right, so match up, they're equal in the sense of 2 parallel lines cut by a transversal in this case. So geometry, semester 1, it's a unit called angles, and it is the 6th lesson called parallel lines cut by a transversal practice. It's on creatormath.com under the geometry tab, all right? Hope this helps.